Investigation Part 4. Let's put these two concepts of the A and the C together. We already talked about how the A, it stretches or compresses the vertical components of the parabola. It also flips it upside down if it's negative. And the C, that thing pushes the parabola up or it pulls it down. Now, if I wanted to graph, how do I think 2x squared minus 3 will differ from the parent function of just x squared? Okay, well, what does the 2 do? The 2 takes the graph and it stretches it vertically. It makes it skinnier. The negative 3 will pull that parabola down by 3. If I want to go over here and I say, okay, fine. Here's x squared. 2x squared is going to look skinnier. The minus 3 is going to take that parabola and pull it down by 3 units. See? So it's a skinnier parabola and it's pulled down by 3 units. What about this one? How do I think negative x squared plus 2 would do? Okay. The negative in front of the x squared will take a regular parabola, that's a regular parabola right here, the parent function is a regular parabola, and it will flip it upside down. Okay, I think it will probably do something like that. But it will be moved up by 2. So my actual answer is going to be 2 units up, and it's going to be an upside down parabola. That's what I'm guessing it to be. Let's check this prediction. Alright, fine. We can check it right here and just say, alright, it was negative, but then I did a plus 2 out here. And how many intercepts does this graph have? Well, it has 2 intercepts. Even though it has a plus 2, it's because this is an upside down parabola. The y-intercept of this thing is at y equals 2, x equals 0. The x-intercept is at positive 1.41, or 1.414 and 1.414, negative 1.414. The vertex is located at 0, 2. The axis of symmetry is located at x equals 0. I mean, I'm telling you pretty much everything I know about this parabola. And it looks a lot like what we have graphed over here. Alright, what about this one? Graph 3x squared minus 4 by making a table first. You know what? I don't want to make a table because I'm so lazy. Alright, so the 3 will take my parabola and it will make it skinny. It will stretch that thing vertically. The negative 4 will take this thing and drop it down 4 units, so it's 1, 2, 3, 4. Here's what my actual graph is probably going to look something like. Let's do it. Let's make a table or whatever. Actually, you know what? Let's just do this. I have a positive 3. There's a negative 4 out there. Look. Made it skinny, dropped it down 4. The x-intercepts of this thing is at positive 1.55 or 1.155, negative 1.155. The y-intercept, well, that's actually pretty easy. It's at negative 4 because it's a regular parabola, just dropped down 4. See? Negative 4. The axis of symmetry is at x equals 0. And I think that's all I can know about this parabola. Alright, let's describe these changes that are going to be made. Describe how this function is going to differ from the parent function. Alright, 1/3 x squared. That's going to take your parabola and compress it. So it's going to be a fatter parabola. Negative x squared plus 4. Alright, it's going to take my parabola, move them upside down. So it's got a regular parabola, moved upside down, but moved it up by 4. That's what my parabola is going to be. What is a parabola? Alright, assume that all sketches, so sketch the changes that they're talking about. Stretch it up by a factor of 2. So that would probably be something like 2x squared. Shift it up by 1. So it would be a skinnier parabola shifted up by 1. Reflect it across the x-axis and shift it down by 3. Okay. Reflect it across the x-axis, that would be negative x squared. Shifted down by 3, minus 3. It would look something like that. That's it.